Okay, we're looking at, I don't know, this is the third or fourth week lecture exercise. We'll call it number 3. I'll put this up on our Blackboard site. We're going to start looking at the plans and specifications that were printed out for this class. You should all have a copy of this. And we're going to start over here with this Student Recreation and Fitness Center, looking through some of the plans. Now, this is only a small sample of the plans that we have in place, and this is the content. I didn't include the specification in this portion, but we're going to look at the site plan, which is under C102. The architectural plans are all listed with an A. The structural plans are listed with an S. So we'll go through some of those, starting with the grading and drainage. So let's take a look at this site plan. Kind of hard to read from this distance, so I'm going to zoom in on a particular area. We can see right in here the hatched area. This diagonal line indicates the new building floor plan. Excuse me. And this is basically the outline of the exterior of the building. I'll kind of explain some of these things. You can see at one time there was an old sidewalk way or a trail that went down through here, a road that went to what we call the deer pens. Now that's been removed. So any existing roads are listed here, you can see, and any new roads are shaded or cross-hatched with this this little dotted effect, so we can see where the new pavement went into the building. We see our stone patio ways out in the front. We see some little boxes with dark squares in them, and those are catch basins. And let's zoom in and take a look at this a little closer. This this line coming down here with an SF in it. Took me a minute to try to figure out what this was. It's actually a silt fence. So this kept any construction runoff debris in the water to be collected. So this silt fence was put in during the construction phase. We have some contour lines. I'll get back to these catch basins in a minute. You can see that the dashed line is the existing contours of the grade. This is an elevation. And these dark lines with the ellipse with the number in them are actually the new grade elevation. So this one's at elevation 142. This is at elevation 140. Then it goes down to 138. So between this line and this line, there is a 2-foot elevation drop. So each of these hard lines is a 2-foot contour. So looking at these catch basins, you see this one is identified as catch basin 3. The line running between these catch basins is called the storm drain. And this storm drain is an 18-inch diameter pipe. It's looks like the slope, the length is 102 feet, and the slope is 0.009 feet. So there's really pretty minimal slope between these two. What we can see on these catch basins, and this one has a rim elevation of 141.4. So we know that this contour is 142 feet. So when it slopes down, it actually ends up about 0.6 feet lower than this contour line when it's set in the ground. It has a 15-inch diameter invert in at an elevation of 133.52, and that's either this roof drain, not sure which. This says 12-inch, so the 12-inch is the roof drain, and that goes at 132.92. This is the elevation where the pipe comes into the catch basin from the roof drain. The storm drain is a 15-inch, I'm going to assume, 15-inch storm drain, has a length of 58 feet and a slope of 0.005 feet per foot. And it gives us, also shows an under drain elevation here with this arrow. So this storm drain runs in at an elevation of 132.52, and that fills up the pipe. And that is going to be higher than the out invert at 132.6. So at 132.6, once that catch basin starts to fill up, when it reaches that elevation of 132.6, it's going to start running down this pipe. And this pipe has an invert on this catch basin, a rim elevation of 137.8. So you can take the difference between 141.4 minus 137.8 to determine what the elevation difference is between these two rims. You can see this is 138, so it's going to be lower than 138 from that contour. The invert comes in at 131.68, so this pipe exits this catch basin at 132.6, enters this catch basin at 131.68. So if you subtract 131.68 from 132.6, it'll tell you how much this pipe drops as it goes down, and of course it's telling us it should be 0.009 feet. Not sure how close that is, but it should be pretty close, or 0.009 per foot. So if you multiply 102 times 0.009, it should equal the difference between 132.6 and 131.68. So that's your catch basins, and as this goes down, you can actually trace where this storm drain comes in to the next one. Has an 18-inch storm drain, length of 54 feet with a slope of 0.01, so it's a little steeper. We got a roof drain coming in here, and then that storm drain, you can see that this actually is a DMH1, which is a drain manhole, has a rim elevation. So if you're out walking on this trail or road, when you look in that spot, you should see a little cover right in the road, probably a round manhole. We'll pull this down and see where this storm drain goes. It actually follows down 165 feet, slope of 0.006 feet per foot to another drain catch basin. Trying to see if this one's listed here anywhere. I don't see that this one. Oops, there it is. Sorry, thought this was a drain line. DMH drain manhole 2. It's a rim elevation of 133. They've crossed out the 18-inch invert in and the 24. We're only going to have one line coming in, and that's this 10-inch, which I believe is this roof drain. If we pull this up, there's your 10-inch roof drain that's coming into this drain manhole at 128.8, and it comes down into this swale. You can see this stone device. The pipe actually ends here and goes into what we call a bioretention cell. And what you see is this is a swale. It's out in front of the swimming pool. If you look out the window there, you'll see that I'm having trouble getting that this is a little pond. Probably got some cattails and wetland grasses growing in here. It's all part of the lead stuff, and all of these storm drains and under drains allow the stormwater to fill up here. So if we have a torrential rainstorm, rather than this stuff all just going directly into the river, it has a chance to fill this pond up and not send all the water out directly. And this is all part of the LEED certification. So as you see, if these come out at 128 all the way around, these drains, it actually doesn't start emptying back out until it raises up 128.5. So it's actually got to put 6 inches of water into this swale before it starts running down this outlet drain, and that would pond down into this area. We've got what's called this level lip spreader, which is basically a drain device that allows spreads the water out, so it will go down into this marshy area, this wetland, allow it to soak in, and then it's going to come down to the bottom. Let me zoom out here a ways. Whoops. And basically empties out across the I think this is the bike trail running across here. So there's another swale in this area. So all this wetland allows that water not to just rush through, but actually filter in there at a fairly slow pace. I'm not sure if this was a footbridge that was designed to go across here. I don't think it exists. They may have taken it out of the contract, but just an idea. So all of these have little notes, and you can kind of follow things down through with the pavement and the stones and the drainage. Anything with an SD is a storm drain, UD is an under drain. Again, our contour lines are up here. You can see there's our parking lot. You also notice we've got some pads out on the back, and let's just zoom in on these. These are just some concrete pads. Has an elevation of 139 feet, and these two here are down 2 feet lower at 137 feet, so there's actually quite a difference in elevation. And these black dots around the outside are bollards, and these are set in the ground. A bollard is just a steel or concrete pipe, could even be wood. It's just designed to protect whatever equipment is setting on these pads. It could be air conditioners, it could be heat units, might be just electrical transformers. Anything that's on here, these bollards would protect it from our plow trucks backing into it, somebody driving a vehicle into it, or just any kind of damage from outside. We can see the roof drain actually comes down out of the building. Sometimes these roof drains are inside. We may see these on the floor plans as we go through. So if you're walking along this new paved sidewalk, you'll see this catch basin right out here. So the structure underneath you don't really see because that's going to be buried, but you will see this square cap on the top. It could be perforated to allow stormwater into it. In many cases they are. So that's one area. So if we look at this, you can see coming up, there's our tennis court area down here by our retention pond. We're coming up the hill, and then this is the main entrance right here to the building. If we look over on the other side, over here, we'll see some steeper hills. So if you're walking down through there, you'll notice how steep this grade is coming off the side. As it goes across this walkway, you notice how this contour comes down and suddenly cuts across until it hits the existing contour line. So this would have been, if this was originally 140 up here, what ends up happening, and it's going downhill, this is actually an area that got filled in. We've got a lot of stone out in this area. So when the existing dashed line is above the new line, that would indicate somewhere that we filled that across and raised this area up. If we look at this 138 where it ties in, we can go back up to here, we can see that the existing 138 would have been right here. Now that's 140. 138 picks up at the road, so it actually is quite a bit of fill coming across this area to fill that area up. Up on this end, near the parking lot, existing catch basins, we have storm drains running across the edge of the parking lot to pick up any water, because this is the high side of the building, so we're trying to pick up any water that might go into that high side, keep it out of the building. 15-inch HDPE is plastic drain pipe. You can see it's running in this direction. If we follow this over, we can see that that runs over and eventually ends up in this catch basin. From each drain line goes down and goes into a manhole on this end, and then the storm drain continues down on the other side of the road. So there's a lot of outside work, and all of our underground utilities are actually mapped out this way so that we can see what's going on. This doesn't give us a lot of detail on the inside of the building. We wait for our floor plans on that. There's not a lot of other information. We can see a little culvert running here across this bioretention area where water will drain in from the bottom of this forested area at a 129.9, and it actually will drop to 128.5. So it's a fairly shallow culvert that comes across, keeps water from flooding across that road. So there are a lot of things in this drawing that indicate what's been done outside to protect the environment and just give us a good record of how things are put together. We'll pop this out and we'll go to our next sheet. Our next sheet basically is a list of symbols, and let's look at some of these. This is your hatching and patterning, basically for the entire drawing set. So if we see a pattern like this one up here at the top, it's fibrous insulation. I'll zoom in a little closer so we can get a better look at these. Fibrous insulation, fiberboard rigid insulation, acoustical ceiling tile. If we're doing a cross section, you'd see it in the tile itself. Quarry tile, structural glazing, ceramic tile, high density decorative laminate on particle board, high density decorative laminate on particle board small scale, glass, plaster gypsum wallboard, terrazzo. If we pull over here to this side, we'll see some, hopefully I haven't blocked this out, I've got a small video window. Gravel, concrete masonry units, this would be for block, steel, or any large scale metal. If we look over, and we got just more, let's just take a quick look at these, see if there's much difference. We can see there's ceiling plans, gypsum board again. Down here we have some symbols for audio-visual alarm lights, loudspeakers, smoke and heat detectors would be this hexagon shape with a D in the middle. Linear diffusers or grills, generally found on a ceiling plan. This note here would just be an S with the polygon around it. It says entire ceiling and room to receive layer of 4-inch batt insulation and isolation hangers. Sprinkler heads, not much, it looks like it's just a circle, but if we look at it closely, you can see it's a circle with a dot in it. We'll look over here. We can see we've got radiant panels, gas outlets, speakers. We pull this up. Access panels, radiant heat panels, mechanical supply diffusers. So if you look up in the ceiling, you see a supply. This is where the warm or cool air comes in. This symbol would indicate where warm or cool air gets drawn out of the building. So we've got both supply and returns on our floor plans and mechanical plans. Occupancy sensor. If you walk into a room, the lights come on, and you walk out, a few minutes later the lights go off. This would be shown on the plans with this diamond shape with an S in it. So we'll go back out. We'll look over on this side. Good idea to look through these, I guess. Metal stud gypsum wall petitions, smoke petitions, fire rated petitions with a 1-hour rating would be shown with this type of wall layout. 2-hour rating. Petition type, see petition schedule. This would be a line with a diamond in it would indicate what type of wall this is going to be. Where corner guards are going to load it. If we see a symbol like this or this with a CG2 or CG1, that's corner guards. So when they're rolling carts of towels and things like that around, we want to protect the wall, so we'd put a piece of corner guard on there, generally a plastic. Match line, if the floor plan is so big that we need to split it into 2 or 3 sheets, this line would indicate where they match up on the next sheet. We look over here. Oops, sorry. Door symbols, ellipse with a number in it would be the door number. A building section. This is the sheet number. The section number, and the direction that we're going to look at that. So if you've got a floor plan, you see a symbol like this, it's actually going to take a section, like taking a knife right through the building and being able to look at it from that particular angle. Wall section, we got this symbol through a wall and we want to see what the detail looks like. It would be detail 2 on sheet A401. Details would just be a circle with a line through it. If we were looking for detail 6 on sheet A802, that's just it. It would be a circle just showing if we want to see a larger detail of that particular. Building elevations, the exterior or interior would be on elevation 3 on sheet A301. Large scale blow up, if we see this type of dashed line around an area and see that it's large scale plan detail number 5 on sheet A205. If we see something like that in the plan, we want to see it to a little larger scale, we can use this to show it, or oops, there we go. These door symbols, storefront symbol, equipment number, there's a piece of equipment. Window symbols would be window W1, W2, W3. This would, you may see a multiples of these. If it's the same window throughout the building, you would see a window type W1 all the way through. Toilet accessory symbols for paper holders or dryers or soap dispensers, that type of thing, would all have symbols listed on the plans. Different types of louvers, interior elevation symbols, looking in the direction. So the interior elevation number 2, you can see the darker line here would be an elevation in this direction. Interior would be number 2 on sheet A601. And then of course we have the room name and the room number identification here. Down at the bottom, and I'll just zoom in, we'll take a quick look at these abbreviations. You can look at them yourself. On the floor plans, if you see the letter DRB, stands for drain board. D.W, drywall. GYP, gypsum. HDRL, handrail. So if you see a set of letters on the drawings and you're not sure what they stand for, look back at this sheet and it should be within this list. It's all listed out alphabetically. If you saw M.H. on the floor plans, I'd think manhole, but it's actually a mop hopper, which could be like a sink where that's mounted on the floor. So there's a lot of these. There's a KD for knockdown and a KO for knockout. Knockdown could refer to like a door frame. They call them knockdown frames when they can take them apart and set them into an existing opening. So it would be a KD frame. So you're going to see a lot of these. Some of them will be fairly obvious. Others you may have to look back at this sheet to determine what exactly they're talking about. Let's move on to the next page, and we see our floor plan for the recreation center. A lot of this will look familiar to you. And again, I think the best thing to do is kind of zoom into this and take a little closer look. You just see the next one's a little, looking for one that's got the, oh, maybe, there we go. A102 is the upper level. Not sure why this one doesn't show it, but I want to use this one. You can see the track area, the overhead areas here. Probably the best place to look at this is over here. And what we see in this area are these numbers across the top. And unfortunately I can't, let me zoom out just a little bit. Yeah, I can't move it. Let me go over the other side. There we go. Numbers across the top, letters down the side. These are column line locations. So structural supports in the building are indicated by these column lines. We can see that column line 2A is this support column right here, and then there's this large beam that runs all the way across. Again, I didn't get it all in there, did I? You can't see the B on this side because of my, there we go. I'll just move my viewing window. So now we got 2A column line, or they may refer to it as column line A2. If we move down, that column on this end is referred to as F2. And there's a column line E2. So it lines up with this line, E. There's actually no column there, but there's actually a location. Now, when contractors and architects and owners are talking on the phone or even live, they will refer to locations in the buildings by the column line location. They may say, in the area of column line F2, and you would know that this is column line 2F, that they're talking about this area of the building here. So they may say column line F2 on page on elevation on the second floor. So it's pretty easy to be able to determine that when you've got this grid system that is there for both the structural integrity of the building, but it also is a good locating device. We know that the distance between column line F and E is going to be 21 foot 6 inches. So we see a lot of dimensions on floor plans that are taken from center line of columns. When the structural engineer is working on this, he'll actually look at placing these structural components into the building before a lot of the layout's done. So a lot of times, based on what the cost of the building is, being able to save as much money as possible and still get the open areas that you're looking for, the structural engineer is kind of the first person that wants to get in there and take a look at it and say, okay, here's where I need my column line. So sometimes if there's a column in the building, you may need to work your walls around that to make it more effective. You don't want the structural engineer to come in after the fact. He needs to be involved in this early. Now here's an idea of a detail. We have a detail 1 on sheet A426 right here. It says opposite, so it's probably looking at the opposite hand of this particular column. Let's see if we can find detail 1 on page A426, and we'll just go down through and see if I've got, if they included A426 in this package. There's 425, oh maybe not, 427, missed it, they didn't include it in this one. But a similar detail would look like this. You can see here's one with a column in it. So we didn't actually get page 426, we got A425. If we kind of zoom in on these, and we'll take a look at this one. Here's detail 8 on sheet A425. We can see the structural steel column. You see that the dimension lines go here, and they give us those column line locations. This is column line 14.9 or G1 and 14.9. This is the center of the column. Shows the steel wide flange beam or column. It's covered with fireproofing. We zoom in on this just a little bit more so we can read the text better. We can see that it has our wall dimensions. There's a precast concrete sill on the outside of the building, so this is the exterior. This is the stonework that's on the outside. If we look at the arrow, it's stone masonry. Shows us a detail on the edge. This is the window. Area is not located. There's a radiator aluminum cover here. Sheetrock or gypsum shows the line of that. These are steel studs lined up here. Steel studs here, so this is all your framework. A larger steel stud out here that's probably like a 2x8. We see our distances between the inside face. Now, so if we want exterior sheathing goes on the outside of the steel studs. And then on top of that, there's an air vapor barrier, could be just polyethylene. There's 2.5 inches of rigid insulation. These are stone masonry wall ties so that these actually slip up and down. So wherever there's a seam that's required to hold the masonry in place, this goes out and gets put into the mortar bed. So it kind of locks this wall. So between the outside masonry veneer wall and the insulation, there's actually an airspace, probably about a 1-inch airspace, to allow moisture to escape and drain out of the building and become less of a problem later on. So these are actually fairly, you're looking straight down on it just like a plan, but it's just a blown up view of that first particular sheet. So we'll go back out of this. I'm going to relocate my box here. And we'll go back out, go back up to our sheet 1. Here we see our basketball courts, our basketball, soccer, floor hockey court, the interior of our locker rooms. Let's take a look at the locker rooms themselves in this area, see if there's some things that we might want to look at. These are the lockers with the benches in front of them. Women's locker room, men's locker room. Your sinks with, I think inside those sinks there's a little round wastebasket next to the sink. There's your urinals, your toilets, your handicap toilet, your shower areas down here for both men's and women's. This is your lockers. You're probably all familiar with this. Your EWC would be a water, well, EWC. I know, let's look at this a little closer. FEC is a fire extinguisher cabinet. EWC is it's a water fountain, but why is it called EWC? So let's go back up to our list. We'll zoom in. E should be about here. EWC. Would that be the one that they didn't put in here? It looks like it is. I know it's a handicap water fountain. Huh. Interesting. I'll blame the architect for that. So we'll zoom back in here. It's probably a water cooler, electric water cooler. We have a handicap one and a regular one, and these are probably at 2 different heights also. They're just saying align these walls. Now here we have an elevation 1 on sheet A606. So this would be an interior elevation looking at that direction. So let's see if we can see these electric water closets. If we look, hopefully I've got E. Let me see if I got E. I got A602. So let's see if we can find an elevation symbol for A602. And probably we'll just pan around here. Kinds of wall sections on 801, A301. I'll make you dizzy here for a second. Oh, here's a symbol here. I know I've got sheet A401. It's only a partial though. Detail 1 on sheet A401 is a cross section. It's through this wall. So this is looking in this direction through this wall. So let's see if we can, if that's the detail that they have. It's A401. So we'll go to sheet A401. Whoops. There it is. Is this detail 1? Yeah, 5 and 4. So if I were to rotate this, I'm actually looking at it sideways. So let me just rotate, see if I can rotate this page. 90 degrees, there we go. Oh, wouldn't you know it. Put it upside down, there we go. So now we can look at what the cross section of this building looks like all the way through from the foundation up. In the first floor level, a little problem driving here, hold on. There we go. Let me just zoom in a little bit more here. Okay, that's within your viewing frame, I believe. So down here at the bottom, we've got some drainage material, probably crushed stone. We have an outside under drain, so this is where the water would collect to get taken out of the building. We don't have the sheet, but you can see there's an enlarged detail of this area on detail 2 on sheet A451. We've got more drainage stone underneath the concrete slab. We have insulation that runs a couple of feet in around the perimeter of the slab. This is a symbol for just backfill or earth. And then we've got a stone topping on the top of this. We have some insulation that is on the outside of the foundation to prevent cold from penetrating through. And that depth of that foundation from grade down is 8 foot 6 inches. This is a section through the gymnasium, so it's probably on that bermed wall in the back. You can see the gym floor actually sets here, and that dotted line indicates where the finish of the gym floor is. So if it's using 3/4 inch hardwood flooring over some strapping, this would be the actual finish floor would be here. So that cement or that concrete is actually depressed to allow for an even floor elevation. As we pull this up, we can see here's the ceiling. This is the track that runs up above, so that's got its track finish, concrete. There's a corrugated metal decking. There's a steel beam construction. Has 2-hour spray-on fireproofing. There's another detail here of this area on detail 12 on sheet A825, which also is not included in your package, but if you had the full package, this would be where you would find those. You can see your grade actually slopes away from the building, so there's a slight elevation difference as this slopes away. Here we've got 2-inch rigid insulation with some concrete material on the outside. We'd have to look at that larger detail to see what it is. As you're running around the track, you'd look up. We've got window areas that look out through. Again, this is on a larger detail on 451. Aluminum grills, painted gypboard, wood blocking as required for these horizontal studs to support things. There's an 1/8 inch stainless steel cover plate right here. Obviously there's a little bit of a curb that runs around there, and then this wood backing kind of supports it. So as you're going around, you may notice this little curb that runs around the track. We have precast concrete panel with integrated rigid insulation and vapor barrier, and then we provide a precast concrete lateral support above the top of this opening. So this actually acts as the header. We've got quite a bit of space between the interior finish walls and the outside face walls to provide insulation and better control between heat and cold. As we get up into the roof area, this would be the roof at the top of the gymnasium area. We have a parapet wall. So actually, what you see on the outside is actually looks like 4 feet. There's probably a 3-foot drop on the inside to the insulation and the roof material and the roof deck. And we've got a steel beam that has some fireproofing around the outside. So every area that's a little bit different all the way around this building is going to have a wall section that you can look at to determine all the parts and components that are used to put that together. We'll go back. Here's our interior elevations, and if we look at this, you'll recognize some things. Let me just see. That's that upper floor. So let's look at this interior elevation. And we'll probably recognize some things. This railing, there's our squash courts or handball courts, whatever they put in there. We've got these are dome skylights during the roof area. The railings that run around the track, that set of stairs that comes down into the lobby area. So this is your lobby as you come in. Administration offices. There's a fitness center up at the top. This is that desk area when you walk in and check in. That platform that people sit on to read magazines and wait to play basketball. So we took a section right through, and notice also that these column lines up here are consistent with the column lines for the floor plan. So column line 6 matches the same column line on the floor plans, and any other elevations that note that would be the same area. And down on this end we've got more doors that go into the fitness studios, and they call this a breakout area. I'm not sure what it's really designed for. And there's your vestibule to go to the outside on this end. Of course, this end you can't see it. It's because behind these administration offices, we see the window wall. It runs along the lower floor. There's an overhang, and then the window wall that is on the second floor where all the cardio equipment is. Now, the other thing you'll notice on this plan is it has other elevations. We see that the first floor is at elevation 136. That's your finished floor. The second floor is at elevation 152. So 52 minus 36 would be 16 feet. Shown right here. As we move up, the ceiling height, or the top of steel from the second floor, is 18 feet difference. There's probably a suspended ceiling in here that kind of makes it look not quite as big. Not really sure. The parapet is 2 feet higher than the top of steel, and there's this clear story at 177.8, and that goes over here. Let's just see what that, and that's this area here, which has a slightly different height on the ceiling for this clear story. That may be for letting light in. It may be part of the pool area too. I'm not really sure. Something in there is allowing it. Could be for mechanical. I'm not really sure. We'd have to look back at the roof plan maybe, which is not included in this section, but I'll have to take a look at it sometime and just see what that involves. We'll go back out. Down here we can see there's a basketball hoop here. So we can see this end, we're looking at the end where the floor hockey is located with the basketball hoops. There's your running track. There's your drop down basketball hoops, your exit doors. And you can see in dashed lines down here the location of the columns and the footings are all in place. Up here we see the main beam carriers for the roof, plus the open web steel joists that run across underneath that. And we'll talk about steel and concrete and some of the materials and methods a little bit later on in the semester, but I thought it's a good idea just to learn how to get around these drawings. Now here's that wall section 2 on sheet A401 is right here, and this is what we just looked at previously, was this wall section right here. There's our foundation. Doesn't show the track on this one though, so it's detail 2. Let's see if that's different than the one we just looked. Oops, on this side you can't. There it is. There, probably couldn't see it. 2 on A401. So we'll take a look at that on A401. Let's just see if I can find it. I'm afraid that that might be the wrong part of the sheet. Yeah, that's detail 5. Thought I had it, we didn't, but if we had the sheet, we'd be able to take a look at it. Down here we have, in this lower section, we're looking at the end of the building. I'm trying to figure out, let's just take a look at this area here. So, conference room, control desks, the stairs. So what we're looking at is looking through the building, through the elevator area actually, at these railings and the stairs. We're actually cutting right through that. It doesn't give us the location of the pool. There's our courts, multi-purpose rooms, men's lockers are all down through here. So looks like that this may be that clear story we were talking about, is actually part of the stairwell and gets up into the mechanical space. Again, notice your column line locations are listed out here. So let's keep going. Interior elevations, wall sections we've already looked at. Some details. These are all detail sheets, all for specific areas of the building in multiple locations, but there's probably a specific detail that refers to this one. This one looks a little interesting here. What's this one? South entry stone wall panel detail. So this is the stone wall on the entry. This is a plan view because we can see our column steel and our door swing is here. So this would be as you enter the building. This is what's inside that stone facade right next to the entries. Again, you see these masonry hangers on the wallboard, the insulation, the concrete, more stone masonry, and then some end panels that look like they're made of solid concrete, precast concrete to be exact. Let's pull out, take a little further down. There's that detail we were looking at, some more wall details. Section areas of this is part of A602, just some enlarged sections. Now we're going to get into some structural drawings. Structural drawings, you'll notice the columns are still the same. The column lines, they all match up. Let's zoom in on a particular area here. And we can see the footing is this gray line around the outside. There's a column. And these dotted lines here would indicate, you'll see it says CJ. It doesn't stand for Claude-Jenkins, it stands for control joint. So as you're walking through that building, you'll notice that they've saw cut control joints between these columns to force the concrete to split at specific locations so it doesn't get all jagged. It's a way to allow the concrete, because concrete doesn't spread over large areas without, there's going to be some movement in the building. It's going to crack. So if we can make it crack in a nice straight line as opposed to a jagged line, that's what we want to do. So these cutouts around the outside of these columns, this is probably structural concrete. There's a footing down underneath the slab to support it, and then these control joints go through. This is elevations. F8 would be the column number, and it gives us the elevation of that column base. Here's a section. We have S502. So if we wanted to know what it looked like if we took a cross section right through this piece, looking in this direction, it's on sheet 502, number 6. So we'll go back out, Let's go down and find. Ooh, that was busy. Still loading. S502. Of course, now I forgot what number it was. Number 6. So 12, 13, 3. This is it right here. Number 6. So looking through that section for the foundation anyway, what we would see is this footing, the under drain, the frost wall. It has what's called a haunch slab, so it actually has a thickened slab in these areas. We can see also that it's a slab on grade, uses number 4 rebar. So a number 4 rebar would be a 1/2 inch thick rebar that comes out in an L shape and ties these together. So all structural concrete would have designations for what it wants on there for reinforcing steel. Let's go back up and take a look at this steel framing plan. When they do steel framing plans, they don't do them really detailed. They're one-line drawings. So if we zoom in on a particular area here, let's try right here. It gives us here's our column, another column. In this direction it has a W21 by 57. I'm not sure what the 8 and the -3, but the W21 by 57 is the size of the wide flange beam. It's 21 inches tall, and it is 57 pounds per linear foot. That's how we designate the wide flange beam. Now the girders that run in between these wide flange beams, you can see here we got a W12 by 19. So this is a 12-inch high wide flange beam that weighs 19 pounds per linear foot. Goes in here, and it's going to be spaced. There's probably a dimension on here somewhere, but this D4 just means they're going to be the same spacing 4 times all the way through. So again, you can just see your columns, beams, girders. This opening here is probably for a mechanical area or stairwell. There's what they call a topping slab. Now here's our track. If you look at the steel running around the track, you can see they're using W10 by 12s, so only 10-inch high open web joists tied into W14 by 22s. So they list these all the way through. I believe these circular pieces are hangers. They're 1.5 inch diameter A36 rod. So if you look at that track, you'll notice some 1.5 inch diameter threaded rod that comes down from the ceiling that actually supports that track, so we don't have any supports coming off the floor. So there's just a lot of different things that you can find from these plans in detail. I think the secret to looking at these plans and elevations and sections and details is not to get overwhelmed with looking at the whole thing at once. If you're looking for something specific, then you can know what the area is, look for a detail or a section, look it up, and find the information you're looking for. If you just look at it and your eyes kind of blur over, then it's not going to be helpful. So just take your time and just focus on what you're looking for. I don't have, if we have any 516 details. We got 516 through 518. There's a 517. So here's a detail looking at this steel elevation. It's on page, or detail 3 on 517. So it's probably a partial, but let's take a look at it on page 517. Detail 3. Yeah, there's detail 3 right there. Framing detail. So let's rotate this document around. Degrees clockwise. Yay! So that shows a HSS is a tubular steel. It says 5x5 beyond. Right here we got that W21 beam, 21 inches high. Goes into this column. The column is a glulam, so it's a wood column. It's connected with these base plates. You can see that this has got an angle piece on it that's made from 3/8 inch. It's a welded angle, but it's a piece of plate steel. PL stands for plate. 6.5 inches long by 1 inch, or by 1 foot 4.5 inches. I'm sorry. 6.5 inches wide, 1 foot 4.5 inches tall. Goes into a plate that's 12 inches, half-inch thick plate by 1 foot 4.5 inch that runs along the beam. And then there's a plate at the top that the W21 sits on. It's half-inch by 12-inch plate, and these are all welded together, and then they're bolted through the glulam. So you can see those details. Now there's more to this. If you actually looked at detail 12 and 4, let's see if we have detail 4 is right here. So detail 4 is looking right at this face of the beam. So we should see, now it's not going to show it to us here. Oh, that's detail 2, column 4. 1, 2, 3, it would be up above. Detail 4, there it is. Pardon my, whoops. They cut it off. That was up here, so it's not shown on the sheet. So anyway, here's some more details of the steel, how things are put together. Really graphically, you can look at these and really, let me rotate this page around. And we'll zoom in on one of these. You can see we've got some threaded rod coming into some turnbuckles with or what they call it, number 7 clevis, 3 3/4 inch diameter pin, typical. What you see here are welding symbols. It says that this is a 1/4 inch fillet weld, and this circle means all around. So that fillet weld where this tube steel, this HSS 12x6 typical, comes into this plate steel, is going to have a 1/4 inch weld all the way around the structure, so it's fully welded, probably off-site. If it was field welded, there would be a symbol on there to indicate that. Again, this is off a column. These are tube steels coming in with some plates on the end of them. We got this thin piece of plate steel here that's probably, it is welded to this piece. So you have a piece of tube steel coming in with 2 flat plates coming off it, and those flat plates referred to as half-inch gusset plates, typical. They're going to be out 1 foot. They're filleted on the edge. There's probably a larger plan somewhere that gives us the details of this on the steel. So just some interesting stuff to look at. You may notice some of this stuff the next time you're walking around the building. So that is the rec center plans and how to read some of these symbols. And what we'll do for a assignment is to provide you with some questions on the pages that you have, and I'll make sure that that the details we're looking at are actually shown on the plan. So I'll ask you a series of questions, and you're going to go find those items within the drawings and answer the questions that way. So you'll always have these to look at, and we'll look at them probably a little further later on, or if you have any questions, be sure to ask me. But the basic reading of the floor plans is something you just need to kind of get into and get used to. It's nice to have the rec center because you can actually go walk through that and notice some of these details now as you're walking around the track and whatnot. I may have some photographs somewhere of as the construction was on, some of these details as they're being put together. So that is my lecture for now, and I'll put some stuff together for a questionnaire that you can have during your lab period. Get back to the beginning. Hopefully you're able to read all that stuff. And there we go, site plan. And you can see again all this hatch stuff down here, wetland area. So that's where all that water kind of washes down into. Next time we'll start looking at some specifications, and we also have the plans for the Milford Bridge that we'll look at a little later on in the Innovation Center. So for now, let's concentrate on this rec center, familiarize yourself with those plans, and be ready to answer some questions on it later on. All right, thank you.